Hi, ladies and gentlemen. We are on page 23 of our notes, and we're looking at section 10.5, transformations in 3D geometry. So the first thing we need to do is define what each one of these words is. So remember, a reflection is just basically a flip. A translation, and to remember reflection, remember FL, you can use to help you remember it's a flip. To do translation, you're just doing a slide. All right, to do a dilation, all you're doing is you're making the picture bigger or smaller. So it's either an enlargement or a reduction. Okay, and then to do a rotation, you're just doing a turn. Okay, but here's something that's really important that you need to remember. If you take a figure and you do a reflection to it, you flip it, the size doesn't change. So we're going to say that the figures are going to be congruent to each other. Remember, congruent means the same shape and the same size. If you do a translation, if you slide something somewhere else, remember the size also does not change. So they're still congruent. Okay? But when you do a dilation, that's the definition of a dilation. The size changes, so it's no longer congruent. But the shape stays the same. It's the exact same shape, so the sides are proportional, which means that they are similar. One thing that's really important is if you have similar figures, the angles are always congruent still, okay? And then if you have a turn, then the size does not change. If you rotate it, it stays the same, so it's also congruent, okay? All right, so let's take a look at example 1. It says, describe a sequence of transformations that maps triangle C to triangle D. So I got to figure out what am I doing in order to figure this out. So this is our starting triangle, and this is our ending triangle. So I know for a fact that my triangle is going to be the same size, so it's not going to be a dilation. So it looks like I could possibly reflect this into this section right here and see what happens from there. So I'm going to try to reflect over the x-axis. So this takes one step down to go to the x-axis, so one more step brings you to your reflection. And then this, you need 1, 2, 3 steps to the x-axis, so 1, 2, 3 more steps down. And then this one right here, you're going to take 1, 2, 3, 4, 5 steps to the x-axis, so take 1, 2, 3, 4, 5 more steps down. So that means that this is where my new image is going to be. Okay? And then I'm going to see if this could possibly take me to D. Okay? So it looks like it's moving to the left. So let's count it and see how many times it moves to the left. So if I start here, it goes 1, 2, 3, 4, 5 to the left, it works. How about from here to here? 1, 2, 3, 4, 5 to the left, it also works. And then from here to here, 1, 2, 3, 4, 5 to the left, it also works. So then I got all my possible answers. So in order to do this, you guys, you have to actually draw in your transformations, just like I drew in my transformation here, to really make sure that it worked. So the first thing that we figured out that worked was a reflection in the x-axis. And then after that, we translated it. So it's a translation 5 to the left. Okay? Right, so the example 2 says, describe a sequence of transformations that maps triangle E to triangle G. So this has several different transformations, but you need to understand that this is your starting point and this is your ending point, okay? So how do I do this? Well, I know for a fact that my triangle is going to move to the left. I'm going to try this and see what happens. So if I move my triangle 2 to the left, so here's my starting point, 1, 2, and then move this 2 to the left, 1, 2, and then move this 2 to the left, 1, 2. Here's a new spot for me. This looks promising, okay? And then it looks like my triangle turned. Since it appeared to have turned, it must have been a rotation, and it rotated, it appears to be 90 degrees clockwise, because this is going in this direction right here, okay? So if I were to turn my paper 90 degrees clockwise, this is what my graph will look like right here. So what I need to do is I need to write down what my new coordinates are going to be. So this coordinate right here is going to be, this one right here, is going to be 0, 0. This coordinate right here is going to be 0, negative 3, because you went down 3 and you stayed, you didn't go left or right. And then this coordinate, you go to the right 2 and down 3. All right, so we would say that that coordinate is 2, negative 3. Then you're going to turn your paper back to how it was before. So go ahead and turn your paper back, and then you're going to graph out these new coordinates. So then you turn your paper back to how it was before, and you graph out these new coordinates. So your new coordinates are going to be 0, 0, 0, negative 3, and 2, negative 3. And this appears to be promising. This appears to be getting us closer to triangle G, which is what we're trying to do. All right, so now we have to figure out what's the last transformation. Well, it's obviously a dilation because it got bigger. But the question is, how many times bigger did it get? Well, this side length right here is 3, and then the full side length is 6. So this is twice as big. Let's just double check though. This side length right here is 2. The full side length is 4. So again, it's twice as big. So that means that you have a dilation of scale factor 2. So when you multiply this coordinate by 2, you get 0, 0, right? And when you multiply this coordinate by 2, you get 0, negative 6. And when you multiply this coordinate by 2, you get 4, negative 6. So then when you graph them out, you end up being right here, and right here. Connect it, and it works for you. So we are good to go for this. So our first transformation was a translation to left. Our second transformation is a rotation 90 degrees counterclockwise. And then our last transformation is a dilation with a scale factor of 2. Okay, and then all these formulas that you have right here on your paper right here are given to you, so we're going to be using those for our set of notes, okay, or excuse me, for our problem set. Let me know if you have any questions. See you later.